Awesome. So let's talk about value stream simulation. We're going to talk about how to build what is the value. But yeah, before that, let me maybe quickly introduce myself. My name is Pavel Azaletskiy. I'm founder and CEO of suboptimal, which is a platform focused on the value stream simulation and digital twinning. But my background is in technology for 20 years. For the first 10 years, I built SaaS solutions in financial sector and telecommunication. Completed research in artificial intelligence, moved to Silicon Valley, worked there at several companies, and the last 10 years I spent at EPAM Systems, and I built the Engineering Excellence Consulting Group, where I realized there is a great opportunity to automate myself to some extent, and this is how VS Optima came into play. So let's talk about like why do we really need to simulate value streams? When I did my engagement in consulting world, driving the value stream optimization exercises, helping engineering teams to find a way to be more productive, I realized that the value stream itself is dynamic. And just to give you a perspective, what dynamics we're talking about, when you come to the team, when they are under pressure, you can have one picture of the lead time. How much do they spend on requirements? How much do they spend on the development, on the quality, and so on? It's kind of an airport line in the rush hours. Or you might come to the team that has enough time to work. I know this seasonality is very interestingly appear in retail when they have no basically releases in production in the last quarter. So the only features that you can implement are in the first 3 quarters of the years. So it depends on where you come to this team, you can have different picture of the value stream. If it's low demand, if it's time where they have enough of slack to work, like in the last quarter, nobody pushed them too hard because there's no deployment, and they have ability, you have a different perspective of the value stream performance. So we need to recognize, depends on where you look at the value stream, you might have different picture. So the question is how you decide what to change and what to optimize and where the bottlenecks are. Another aspect of the value stream when you're talking about optimization is structural dependencies. The way how you structure the teams really matters, and it might be cross-functional or component team, and might have shared services. So how does this dynamic interplay? If you have, let's say, you work with the product team, but they rely on the certain shared services, it might be infrastructure, it might be security, it might be database. Even though you optimize like the very productive team, the product can be built in a matter of day, like any feature or any code change can be deployed to production in 1 day. But if there is a dependency on shared services and they are not optimized, you cannot do much about. So you need to look at the system as a whole with all dependencies if you want to really increase or shorten lead time, improve certain performance attributes of the value stream. And another part is variations of variability within the system, within the value stream, right? We talk about variability of the load, depends on where you come to the observation of building the exercise of value stream up. You might have different lead time structure, different performance metrics, but it also very important to recognize variations in size, in the way how the team are working. Let's say it might be the case that certain features gonna take longer time, the way how, if you have component architecture, the distribution between how many features go to one component versus others also matter. Like, do you have enough capacity, engineering capacity to support higher demand on the core module of your product versus peripheral? So it's really important to look at the capacity variations as well. And I realized it's very hard to really come up to the ideas, okay, where the bottlenecks are. Like, do we really need to implement I don't know, like code review, for instance, or do we need to prioritize test automation, or do we need to fix the dependency on the database or infrastructure team? Where's the bottleneck? What gonna move the needle? And this is where I realized that we need to have simulation, because this is dynamic system, it's non-linear system. And there are like couple of, I try to kind of condense this, but the idea is that the value stream, performance of the value stream depends on the structure, right? When we're talking about organizational topology and the value streams itself, how do they connect to each other? Capacity, like on each of the components, do we have enough capacity to fulfill the demand for this specific component or for the product itself? What is the variability in the value stream? And the variability might be in the processing time. So how long does it take to implement the specific task? Or on the load, what is the pressure on the team to produce certain backlog, a certain amount of features? And then through this value stream, all these parameters entail the performance attributes, like exactly what's going to be the lead time. It all depends on those variables. What would be the quality? It depends on also all these variables. If you don't have enough capacity, you don't have enough quality, you don't have enough time to fix, you're going to have a trade-off. If you don't have enough capacity for engineering development, you might have a longer lead time. Throughput might suffer as well. Utilization will be high if you don't have enough capacity, right? And it's not good as well. So we know that utilization should be around like 80% at best. And cost per item will fluctuate as well. So how much does it cost for us to produce the feature in average, if you will? So it's not linear, and it's very hard to figure out, okay, where the bottlenecks are. And this is why I realized, like, should we need to explore the how we can simulate, if we can, the value stream and all this complexity, and to make better decisions about what to change, how to identify the bottlenecks, and what kind of changes, if we make, what would be the implications on the performance. And I saw some quote in the chat that not all models, so all models are wrong, but some are useful. And I believe this is how we should treat the simulation models of the value streams. It gives you the system perspective. Okay, how in dynamic the value stream gonna work? What if you're gonna have higher demand in the feature development? Does your team is sufficiently staffed to fulfill the higher demand? Or who are lacking? Do you need to hire more database engineers, or do you need to hire, I don't know, quality assurance guys? Because those are elements that are on the bottleneck side. And to make it happen, I believe we can leverage three concepts. So there are multiple types of simulation, but I believe what we can really benefit from, there are three of them that are relevant to the way how we can model value streams. The first one is agency, right? So we have people performing activities, and they have it takes some time to execute. So we need to understand the timeline or distribution of the feature implementation. So we have staffing model, we have agents within the value stream that perform activities. So this is this part. Another part, the system is dynamic. We can change various parameters and see how it play out. And there is a stochasticity there as well. So we don't talk about, okay, how exactly it's gonna work, but we can talk about, so for instance, processing time gonna take from 1 to 2 days. When you run simulation, you have no idea how exactly it's gonna take, but you know the range, and it gives you the sense on the average level how the system behaves. So to see the dynamics of the system, and discrete, you can really like see the state of the system at like on a daily basis, on a weekly basis, or whatever time frame you want to simulate. So get the perspective, okay, how much my backlog grown? Like, do I have enough capacity on QE, quality assurance, and how do they perform? You can see exactly what is happening along the line. And to build the models, to build the value stream model, I believe there is a combination of value stream mapping exercise and certain data analytics. So first step, of course, is to create the process map or value stream map. It's collaborative exercise. You see the perspective how people think the process works, and with the previous session provide comprehensive overview how to do that. But the next step is to really calibrate with the data layer what we learn from the exercise with the team members. And it might be interesting, eye-opening experience because like data can speak and contradict to the assumptions that we put in the process map. So we can calibrate and reconcile those deviations. And once we agree, okay, this is exactly how system behaves, you can run simulation and explore different scenarios and validate hypotheses. Okay, what would be if you introduce test automation that's going to shorten test cycle from, let's say, 1 week of manual testing all the way to 2 days, because one day, let's say, you run tests, and the second day you can review them. And you can find the ROI of that, and you can find the performance impact, and you can find what would be the next bottleneck in your process, and also start thinking, okay, what's going to be next once we implement the test automation, for instance. So how it might look like, right? You do the value stream mapping through the interviews, observation, workshops. You create the structure of the model. I usually capture the timeline, the lead time elements, but as for me as a reference, because more I focus on the data layer and calibrate with what I observe in the data. There are different type of exercise that you can run, like process mining. There are a bunch of tools, including open source, that helps you to reveal the structure of your flow through the logs. There are other elements, exercises like agent mining that gets you ideas how about behavior elements of elements itself, queue constraints in the queue if there are, and you can get the real value stream simulation model. You can again run different scenarios, look at the different performance characteristic, like say lead time comparison to the process mining, process time, activity ratio, and those are dummy data. I'm gonna show you example. Yeah, and you can find, okay, this is reasonable. This is how I can tackle bottleneck, and maybe the rest is suboptimal optimization. I don't need to take care of or to think about other things. I need to prioritize the efforts to tackle exact one bottleneck and get the system effect. So let me show you just simple example what I'm talking about. So this is very simple software development process, quite waterfallish. So you have starting element that reflect the pressure. So how many items or features come as a requirements for the development. And I put here like small load 0.2 a day. So it means once in 5 days. Then we have a requirements analysis step. And just for simplicity, I put one business analyst. It's gonna take 2 days for him to produce the requirements. And I have a development team, very small, like 2 people, 2 engineers. They take 1 day to implement the feature, and they work in sprints. So basically, it means that you have a cyclicity at the beginning, like requirements analysis work as a kind of on the continuous basis. Whatever comes, processed, put in the backlog, and development team takes once in 2 weeks whatever is available in this queue. And what we also can model, and by the way, this is what I struggle when I run the value stream mapping manually, those backward loops or backward flows that add non-linear behavior. So for instance, we know that 20 features that are kind of described by analysts, 20% of the features described by analysts has certain, I don't know, defects that needs to be addressed. So they're not going to be taken in development. So you have a backward loop here. And the same, you have the backward loop here in quality assurance. And those might be very important impact. This might create a very important, significant impact on the performance of the value stream. So it's worth looking at that as well when you do the interview, asking people like how often like you really send back to the development, sorry, the features once you validate them. So how much rework exists in this development step. And then let's say deployment. When you run simulation, and I do it right now for 35 days, 365 days, you can see the on aggregate level what the performance is. Let's say we have processing time, so basically value added work, 4 days and 10 days lead time. And it seems it's more or less stationary. Oh no, it's growing. Okay, it's growing. If it's growing, it means that we have more features coming into the process that we can really execute on. And I guess since this is a red step, this is the bottleneck. We don't have enough capacity on the requirement analysis. And this is how you can see the queue size is growing. And this is dynamic of the process. So you definitely need to prioritize on all kind of brainstorm how you can streamline, make it shorter. Maybe you can parallel or basically hire new PA. You can get different performance characteristics. Another aspect that also important to look at, there are different scenarios, different flow. This is straightforward flow. It has its own characteristic and its own bottleneck. But there are others. When you have a feedback loop here, the development will become a bottleneck here. And so on. You can explore different flows, scenarios, and find what you want to optimize. And play with scenarios and find, again, run simulation, compare the performance attributes here. Just to give you a sense of what it might look like, let me open. We recently did the exercise with the software development SDLC process, and we ran a couple of experiments that just show you. So we have as-is model. It's rather complicated. I actually can show you. And we have white paper for that you can later read. So it's rather complicated process. There is a set of collaboration with on the analysis side. There are a lot of steps on the design with partners, the way how you split the work and test. So there are a lot of feedback loops here. It's very hard to predict like what actual performance is going to look like. But what we did, we build as is, we make sure, okay, it's calibrated, reflect the reality. And then we did different experiments. Okay, what would be if we're gonna improve the way how features are developed? Like what would be the productivity impact? If we're gonna leverage already built components, what impact it's gonna have? Test automation, all these features together. And what we did, we just run simulation with the high load on the process, on the value stream, and see how much does this structure gonna chew. And we see like who is like best impact on the productivity. But the cost and the rest, like speed, will be not actual proper comparison, because we see that the less features are delivered here. Therefore, if we look at the cost, it will be, we just divide by different numbers here. So in this case, we're on different experiment. We're on experiment where we have minimal load on the value stream, and we compare how fast the value stream can deliver the feature without like choking because of high load, and what would be the cost of that feature. So it gives us also very good comparison, and you can make a decision. Okay, maybe we'll like test automation worth doing first, right? Because it has high impact on the productivity, high impact on the other parameters. And then you can explore different, you can proceed with other optimization scenarios. But you can, again, play with other changes. You might have hire new team without changing the process, or without changing the structure, like capacity changes, right? You can explore the impact of that as well. So let me jump back to the presentation. It's a very powerful tool that you can use to communicate the impact. And I believe when we're talking about value stream mapping, it's quite time consuming and often quite challenging to continue to run this exercise once you complete the transformation or complete the improvement. With the model, you can you already build it once. You can tweak just parameters once you complete the transformation, but it's definitely help you to reduce resistance to change, because you can explain the impact. The goal will be clear. You can identify the bottleneck. You can calculate in a matter of second the ROI. You can communicate it properly and show. So here is it. This is, if we're gonna do that, this would be the outcome. This is confidence interval of our outcome. So let's prioritize this initiative and go for it. So there are definitely like impact on the challenges when we're talking about continuous improvement and persuade stakeholders to move forward. But you also can take the digital simulation, digital model, and embed in your routine as a digital twin. Once you build the model, you can connect it to the data layer. So it will continuously show what exactly is happening, given the dynamic and the load, dynamic in capacity, dynamic with the different aspects of the model. You can see what is happening, what the problems are, and you can always come up quickly to the suggestions. So you don't need to spend a lot of time going back to the whiteboard and create the value stream all over again once there's a certain change implemented. You have it built once, connected to the data layer, and you can always see what is happening. And you shorten the decision-making cycle significantly. The idea is to have the simulation model as a part of the enterprise ecosystem, where you have completely like full digital twin of the all value streams, and you can see exactly what is happening, what the problems are. If the business has objective to scale the delivery or repurpose the engineers or reshuffle the team structure, you can really quickly understand the implications of those changes on the bottom line and the performance of the entire delivery organization. So yeah, there are interesting aspects that once you have a model, you can work with LLM, enable people to really speak to the value stream, like asking question like what the problems right now are, what should I do, like given my demand gonna grow in the next quarter twice, and it can be explained. So we have like digital advisor, if you will, that can easily enable, again, the fact that you have a digital model, you can connect it to LLM as well and have ability to interact with that, and it can help you to facilitate the better decisions, given the all numbers and statistics that can be assembled. But I believe the ultimate value is the way how the value stream simulation can transform the continuous improvement cycle, really shorten the decision-making time, often spent on the research and analysis of what actually the problems are. You're always going to know. Once you connect the model to the data layer, you can like amplify the speed of improvement significantly, or improve the productivity of your lean or agile transformation team, because they can handle much more value streams in the same amount of time and help more people to improve the performance. Yeah, this is the last slide just to think about future. So once we have a lot of models, right, they can interact with each other. You can see, and you have basically the digital advisor, if you will, in your company that can suggest what is happening with the value stream, given the simulation capacity and real-time update. So it's something interesting to explore. Yeah, this was my last slide. If you have any questions, please, I open for the conversation. Would appreciate your feedbacks, thoughts. How do you feel, whether it's applicable for your reality and for your work?
So maybe I can start by, this remind me of what Helen said at the beginning, Pavel, and I don't know if you joined for that part. And I see you joined later, but I didn't know if you joined and joined back. But like she said, in the sense that she's seen more of like value stream officer or something like that. And your whole presentation reminded me in a sense that this is really what like executives in organizations should have people looking at when it comes to structure, when it comes to flow, when it comes to like, the slides that you started with, the different types of systems. And it's so rare. And I think even for probably most of the audience, I'm just guessing here based on just what I've seen so far, and it seems far-fetched. Yet, like for me, it seems like this would be essential thing for any organization to have in order to understand what's going on. Because this goes back to the panel discussion that we had too, and I don't know if it was Al or somebody else that said like, if you ask, or Karen said, the first thing that I ask executives is like, how well do they know where things are? And nobody knows where they are. And the simulation and what you've described really kind of highlighted like what senior executives in organizations should be pushing for, to have people looking at things like this, looking at these simulations. And then one other thing that I asked is like, just imagine having AI helping you with what you
Yeah.
just did. So anyway, that's my 2 cents. I thought it was very interesting and uh, helpful to think about, but I'm interested in others, so I won't take more time, but thank you. I really appreciated the presentation.
Thank you, Elgin.
I'd like to ask a question. Hey, Pavel, good to see you.
Hey, good to see you, Richard.
Um, Question about where you source the data from. And I saw another person had another great question too, and that is that we always have this problem with the quality of the data.
Right.
So, but really, I'm curious about the first part, is where are you sourcing this data from?
Yeah.
And, how are you finding is it easy to connect? How is this exactly done?
So for the data integration, depends on the value stream. You might have different systems supporting your execution. It might be like Jira, GitHub, like various CI/CD tools and whatsoever. So all of them produce logs, and logs are pretty much typical.
Okay.
They definitely have activity that executed, timestamp, uh, people, and an object that we're working with. It's code or build or whatever. So, and you can get those logs and recreate the structure. There are, again, open source algorithm. There are tools available for process mining, and you can get the model created through the data. The next question is more tricky about the quality. This is why we need to calibrate the model, right? It's not always the case that we have processes properly digitalized and we can really rely on the data traces. Then you calibrate the model with the people, right? You can see what is happening on the data layer. You can see what you capture in the value stream map and can reconcile to make sure, okay, the model really, once you run the simulation, produce the performance results that the same on what people observe if we cannot trust the data. Or if there are certain data source that you can trust, then you just calibrate the rest of the model. But you already have a data point that can expedite the calibration exercise.
Right.
That brings up another question issue, which we run a lot of times into, is that different parts of the organization use different tools, different metrics, and this was brought up. And Heidi and Helen, I believe, well, Helen, like at least through Value Stream Consortium, have they've been talking about how we need either a single tool or better way to have better data, because it's just there's no lot of confidence. You can recalibrate and calibrate, all day long if but the same thing is, I think it gives us insights. Anything will give us insights that we can create hypotheses around and then validate. So
Yep. Yeah. If if there are multiple systems available, but you can trust some of them,
yeah,
it's already a good point to ensure that the model properly reflect the dynamics in the past.
yeah,
Right? And make an assumption that these dynamics proceed in future, you already have a calibrated model that you can play with.
yeah.
So it's not necessary, especially with software development lifecycle, you have so many systems that produce logs that like some of them is trustworthy.
Yeah. I think that's easier with yeah. I was thinking more like with manual, and you look at a value stream across both business and IT, that where things are not as, you know, if you want to look at a systemic view of a bigger value stream, that's a lot harder. With IT systems and things that are tracked, I think that there's a lot more. But if you look at optimizing the whole value stream, what you showed is just the development value stream, or, you know,
Yeah, just a small example. Yeah.
but I think it's great, like just to even for executives to think about how do we get to a point where we have more confidence in where the bottlenecks are in our organization and how do we optimize it. And these type of models, I think, are great and
Yeah.
it's not very common to see.
Yeah. Speaking about
Yeah, well,
sorry, go ahead.
yeah, I was going to say, in a certain sense, this is more accurate than, let's say, taking data just simply from a Kanban system. Because as an example, developer says it's done, we move the item to done, and that's it. But then we know what happens. It stays in a queue waiting for deployment, and it doesn't get deployed until 3 months later. So since you're getting it from the logs, really that's the best source of truth, is really from the tools themselves rather than what people are manually tracking themselves.
All right.
Yeah. Yeah.
Would you
And
agree with that?
I agree with that. Yeah. And you can have like multiple systems. Yes, the deployment system might be different one, but you can trace, okay, when exactly this build was picked up and deployed. Yeah. Another thing that Miljan, you mentioned, when you do assessment, like where exactly you need to optimize and what would be the ROI like of optimization, which is also pretty challenging. Sometimes when you do the assessment, you might find, team doesn't have enough good code review practice. They don't have infrastructure like as a code. They don't have like this and that and that. But do they really move the needle? Like, should we like jump on all these improvements?
Yeah.
Or we just need to focus on exactly what can move the needle. So I found like very challenging often to find those are initiatives that we need to prioritize first. And the
Dude,
question, yeah,
and I think it goes back to like all of this is a guesswork for most part, because even still, it's just you know, we don't have a lot of confidence in these things. Even, you know, the data that comes from the logs, there could be some subjectivity to it. But I think, right, like the biggest benefit I see here is like seeing in the story or seeing what is really going on here, creating a hypothesis and then validate. Hey, we think this is what's going on based on data that we have. How could we actually validate that this is an issue? Or how could we validate that this would be the biggest bang for the buck if we address this issue, right? It's just that those type of conversations are not happening. You know, it's like, you know, run the annual projects, go through. If you ask people where the issues are, nobody knows. It's like, let's move on to the next thing. And the thing is also nobody's incentivized to look at this. Everybody's incentivized. Hey, Pavel, what are you gonna do at the end of this year? So I just find this highly interesting and helpful, but I also just see how much people are not at the executive level interested in this because they don't have time. And this goes back to the question that I asked is like, how do you get executives to buy into stuff like this? And pretty much the question or the answer was like, well, you know, like Karen said, don't bother if executives are not interested. So I don't know. Those are just thinking out loud, but those are my thoughts. What
Yeah,
about
but you did provide some projections on cost, right?
yeah, yeah. You
And
can calculate ROI. Yeah,
yes, so I think that one of the things would be really helpful if that was zoomed up, you know, and you could kind of project out, if we did nothing, in the next 3 months or next 6 months, next year, it's going to cost us $20 million or
yeah,
whatever the number might be if we don't do anything. If we make this one improvement, it will gain this much. So I think that this would give executives a way to justify doing improvement efforts
that?
because now you have facts. It can be quantified. I think where we have trouble with value stream management, and, it seems so geeky. And I admit I'm one of the top geeks in the world, and that's okay. I mean, I know I'm in good company here. And so we like this stuff, but I can understand where we really have to put it into business terms and
Yep.
speak the leadership speak for them to really get this. And they probably wouldn't be interested in the minutia, but probably the top line numbers, I think they would be, more of a report or a dashboard that looks like PowerPoint, of course. Everything
Yeah.
has to be in PowerPoint to show it to an executive.
Yeah, and it's cumulative effect. If you do improvement, it's occur like over and over again. Like so.
Yeah,
definitely.
it's like compounding interest is what
Yep.
it is. You keep saving on that savings. It's quite amazing. So I think we're going to see a lot more take up with value stream management, but it's not going to be an easy road, because just the term value stream management, as soon as I say those words, it goes over executives' heads, and in fact over most people's heads, even though this has been around for quite some time.
Yeah,
It,
well,
it,
that's
it
the
just
issue.
takes a while for it to be adopted.
That's the issue, because the executives need to understand it and be able to say, hey, Pavel, here's, whatever you need. Here are the resources, whatever you need, do this. You're responsible for this type of stuff. And it's just that if you don't, as an executive, if you don't have that type of understanding, and you don't understand what Pavel here just explained, or what we've been talking all day, it's going to be very difficult sell, and only like what I've seen lasts for a couple of years at most, and then somebody else comes in and it's like, what are these people doing? No, Pavel, get away. And so we have few minutes. I know personally I've been dominating. Arnold has a question. What other questions do you have, Arnold? Let's start with you, and then see others that might have.
My question will be the same with the one that I asked Heidi about. Now, since you are using the simulation, maybe you have a better calculation. When in the value stream mapping, sometimes we have a parallel process, right?
Yep.
Then how do you calculate those value every time and wait time when you have a parallel process? Do you have a better way to calculate that?
Yeah, on the integration side, right? Or you have waiting and different dynamic. You might have like cycle time for one process shorter than another, and you have an interesting dynamic in this case. Yeah, it's very hard to answer when you just look at the numbers and statistics in Excel.
Yeah.
So you need to have a model to really quantify the impact. Maybe it's better to have harmonize them to have the same cycle time, or like merge them together to have a cross-functional team. And instead of like doing the two streams in parallel, you can have one, but in a different organizational structure. So you can do this type of analysis and come up to the best option.
Yeah, it seems that needs to be mixed with different responses, then using the model and then see how accurate that is.
Yeah, and it's definitely worth calculating we should calculate ROI on the business term. Like one of the executive asked me, which triggered this journey to make this platform is, okay, so you ask me to stop the development, invest in test automation for, let's say, 2 months, but I have a committed roadmap to the end of the year. So the speed I'm gonna get, is it enough for me to keep my commitment and to justify this investment, or should I go back and reshuffle my backlog and my commitment for executive? So there are two questions here, like the ROI from investment, like how am I gonna get enough time, like speed from changing the priority for and implement test automation, and versus like the payback, how fast can I pay back these investments, and whether like backlog I can deliver. So it's very hard to reply without having a model.
All right. Okay. Thank you.